All right, pre-calc group. Today we are looking at simplifying trig expressions as a single trig function or a constant. So here's some old stuff that we've picked up already. Remember when we first started looking at the unit circle, we picked up that the tangent of theta was sine over cosine. When we did the reciprocal functions, we had the cotangent was 1 over tan. 1 over tan of theta were reciprocal. And so then we have cosine over sine for the cotangent. And then we have secant of theta is 1 over the cosine, and the cosecant is 1 over sine. Okay? And then also in the unit circle, we picked up this little Pythagorean identity right here. Sine squared plus cosine squared equals 1. There are two variations of this. What do I mean by a variation? Well, meaning I can rewrite this equation so it says sine squared of theta is equal to 1 minus the cosine squared of theta. We have to know this. And we can rewrite it saying write it in terms of sine, so getting the cosine squared all by itself. Cosine squared of theta equals 1 minus the sine squared of theta. Okay, so this is the stuff that we need to know. You need to memorize this. All right, rules for simplifying these trig expressions. Number 1, we're going to change everything, so all trig expressions, to sines and cosines. Number two is lengthy, meaning we have to simplify. Combine like terms. We add fractions, okay? Combine, we add fractions. So that means we have to have a common denominator, okay? We have to get common denominators, all part of this simplification. Okay. So you multiply, you simplify. Our whole purpose is to clean it up as much as we can, so we have either a single expression, or when all else fails, the final step is we apply our sine squared of theta plus cosine squared of theta equals 1, and its other variations. Okay, so I'm going to write it using just single letters. S squared equals 1 minus cosine squared, or cosine squared is equal to 1 minus sine squared. All right, let's look at a couple. So our first one, number 1, is cotangent squared theta plus 1. We're going to write this as a single trig expression. So rule number 1, change everything to sines and cosines. Well, cotangent is right here. Cotangent is cosine over sine. Well, there's a square here, so we can't forget the square. So we have cosine squared of theta over sine squared of theta plus 1. So we just did rule number 1. Rule number 2, we have to simplify, combine. So I have a fraction here plus 1, so I have to combine these two. So that means I have to have a common denominator, which is sine squared. So this 1 is rewritten as sine squared of theta over sine squared of theta. So now my one denominator and then my numerator is cosine squared of theta plus sine squared of theta. Okay, so now we're at this fraction here that we can't, if I cancel these, I'm back over here. I'm back right here. So now we're on rule number 3. I can't combine these, but rule number 3 says apply this. Well, what do we know? Sine squared plus cosine squared equals 1. Well, cosine squared plus sine squared, what is that equal to? It's right here. It's equal to 1. So this entire top is 1 over sine squared of theta. So this is a single trig expression, 1 over sine squared of theta, or we can write this as this is equal to the cosecant squared of theta. So we just simplified this trig expression as a single trig function. So either this or this. All right, let's do another one now. Number 2. Cosine of x times the tan of x. Seems pretty easy. Okay, can't multiply them together, totally different functions. Okay, it's like saying a times b, and so it's just ab. All right, so now change everything to sines and cosines. Well, that's already a cosine, there's nothing to do here. Tangent can be rewritten, it's right here, sine over cosine. So tangent is sine of x over cosine of x. And I'm going to rewrite the cosine of x. Okay. Now, we simplify, combine, add, multiply, whatever you have to do. Remember, this is a fraction times cosine of x. If you need to, you put this over 1. And what can happen with these two? That's right, they can cancel. So, 1 and a 1. So we're literally looking at sine of x. Let's look at another one. Cosine of a times the cosecant of a. All right. Rule number 1, change everything to sines and cosines. That's done. Cosecant is 1 over sine. So the cosecant becomes 1 over sine of a. Okay. We're multiplying. There's nothing that I can cancel here. If you need to, put a 1 under there. So now all I have then is multiply straight across. Cosine of a over sine of a. And cosine of a over sine of a. Remember, there's nothing to apply. There's no squares in here or anything like that. But what is cosine of a over sine of a? That's right, it's right here, cotangent. So this mess right here, this product is actually equal to the cotangent of a. All right, let's do a couple more. Cosine of b times the tan of b times the cosecant of b. Okay, what's your rules? Number 1, change everything to sines and cosines. That's done. Tangent of b becomes sine of b over cosine of b. Cosecant of b becomes 1 over the sine of b. And there's nothing to do with this, so I'm just going to rewrite it. Now, what happens? Well, you multiply. Things cancel. Cos b cancels cos b. Sine of b, sine of b. What are we left with? There's all 1s here. What does this equal? 1 big fat 1. So this product right here is just simply equal to 1. Number 5. Secant of theta times 1 minus sine squared of theta. All right, this one's I mean, I can multiply, distribute. There's nothing wrong with distributing. But I also noticed something here. I'm going to change this to sine and cosines. Oh, and so secant is 1 over the cosine of theta times this mess. But you need to recognize this. I mean, the order in which we do our rules should not matter. Okay? Because right now, what do you notice about 1 minus sine squared? That's right, it's right here. 1 minus sine squared is equal to the cosine squared. So you know what I'm going to do? I'm going to do my replacement right now. Why do I have to do the extra work? So I'm going to do this replacement. 1 minus sine squared is equal to cosine squared. So inside this big giant parentheses, all of this becomes cosine squared of theta. Let me get this out of the way. So, what happens now? Oh, this. Cos cancels with the square, so we're just left with cosine theta. Nice simple one. Okay, 2 more, and then I'm going to show you something. Cosine theta, tan squared theta plus 1. Okay. Now, rule 1, change everything to sines and cosines. Well, this right here has to get changed to a sine and cosines. That's done. Can't do anything with 1. I mean, technically, you could. I mean, 1 is sine squared plus cosine squared, but no, we won't. I'm going to leave it. So, follow my rules, change it to sine and cosine. So I have sine squared of theta over cosine squared of theta. Now, I'm going to use my distributive property because there's nothing I can do now. Remember that your multiply, combine, your rule number 2, we simplify. We're going to try and make this one expression. Okay? So I'm going to distribute. So the cosine theta times this fraction is going to cancel that square out. So I have sine squared of theta over cosine of theta plus, I'm going to distribute, I have cosine theta. Okay, remember, I multiply cosine of theta times the cosine squared down below here. Remember, this cosine would cancel the square out. So sine squared theta over cosine theta. Okay, so we're still on rule 2 because this is not a single expression. All we did was the distributive property. So I have a fraction here. I have to add these 2 pieces together. So if you need to, you put a 1 under here. And we're going to multiply top and bottom by the we need a common denominator, which is cosine theta. So I'm going to multiply top and bottom by cosine theta. And I'm going to write it as 1 denominator. So my 1 denominator is cosine theta. And the top, sine squared theta plus cosine times cosine is cosine squared theta. All right, what do we know about sine squared plus cosine squared? Now we're on rule 3, can't do anything else. Rule 3 says what? Sine squared plus cosine squared, that's applying this, is equal to 1. So this entire top right here, this entire top is equal to 1. So I have 1 over the cosine of theta. So this big ugly mess right here is 1 over cosine of theta, which we're going to change it to secant theta. Okay, as our single trig expression. Either one. I mean, if it's a multiple choice, well, then you got to find your answer. It depends on what you're looking for. Maybe we just want it in terms of cosines. So then this is done. Okay? Maybe you need to have this. It all depends on what you are doing. All right, last one. And I'm going to show you something else. So cosecant of theta sine of theta minus sine squared theta. All right, so what do these two mean next to each other? I didn't put a times. If there's no sign in between them, no operation in between them, it's a multiplication. So this is saying cosecant theta times sine of theta. I don't need to put a dot in between them. So this is a multiplication right here. So this function times this function. Rule number one, that's right, change everything to sines and cosines. Well, cosecant is what? That's right, 1 over the sine. And then times the sine of theta minus sine squared theta. Well, what do we know about these two signs then? That's right, they're going to cancel. So I have 1 minus sine squared of theta. Well, those cancel. And then rule number 3, what do we know about 1 minus sine squared of theta? That is equal to our cosine squared theta. Remember, apply rule 3. Okay? So we just did simplifying trig expressions. Now what I want to show you is something that that's an offshoot of our Pythagorean identity. I'm going to show you how we could have used it on a couple problems. So this is our Pythagorean identity. I'm going to use the letter x. Okay, that's Pythagorean identity that we picked up when we did the unit circle. Okay, I'm going to do one thing on this Pythagorean identity, and I'm going to create a new identity. And what I'm going to do is I'm going to take this expression, and I'm going to first of all rewrite it. And I'm going to divide everything. What I do to the left, I'm going to do to the right. I'm going to divide everything by sine squared of x. And look at this equation that we create. I know right now it looks confusing, but what do you know about sine squared over sine squared? Well, that is equal to 1. Cosine squared over sine squared, well, what that is the cotangent squared of x, and is equal to, and then 1 over sine squared is cosecant squared. Believe it or not, this right here is another Pythagorean identity that you should memorize. Okay? So 1 plus cotangent squared of x is equal to the cosecant squared of x is another Pythagorean identity. Okay, so I'm going to start with this one again. And instead of dividing by sine squared of x, I'm going to divide by, you named it, cosine squared of x. Now look at what happens. Well, sine squared over cosine squared, that's right, that's tangent squared, plus cosine over cosine, that's 1, equals secant squared of x. So this is our other trig identity, a Pythagorean identity. So these two right here are just the Pythagorean identity just rewritten after we divided everything by either sine or else we divided by cosine. But this is another identity that you should memorize. Why do I say that? Well, if you looked at my first question, remember my first question? Cotangent squared of theta plus 1. We did all of our beautiful work and we came up with cosecant squared. Well, guess what? There it is right there. 1 plus cotangent squared of x is equal to cosecant squared of x. So instead of doing all of this work, we could have said, oh, that is just simply equal to the cosecant squared, because that's that trig identity. I did another one like that. Now, similar. This number 6. We did this cosine of theta times this. This right here, I'll do it. I'm going to rewrite it down below. I'm going to rewrite it down below here. So our problem number 6 was this. Cosine of theta times tan squared of theta plus 1. Okay? So that's our problem number 6 that we did right here. This is what we did. We changed everything to sines and cosines. We cleaned it all up and we came up with secant. Okay? Not hard. But now, look at what happens if we apply this trig identity. This Pythagorean identity right here. Tan squared of theta plus 1 is equal to this. Oops, secant squared of x. Oop, theta. Let me just start over. So all of this right here, we wrote as that, times my cosine of theta. And then secant of theta, you named it, is 1 over the cosine squared of theta. And then those can cancel. So we have 1 over the cosine of theta, which is secant theta. Okay, so we did it in a lot less steps. Okay, we did this question here in less steps than this. So, if you know, recognize, 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 recognize. Recognize. You're going to see that in the homework where you could use these identities right here to clean up your mess, and it may make your work a little bit easier. Okay? All right. You have a nice short homework assignment. Good luck with it.